Hello friends, once again welcome to my channel Physics Ki Pathshala. Today I am presented before you to discuss a very important point of the class 12th physics CBSE chapter 4 magnetic effect of the current. अतः आपसे रिक्वेस्ट है कि आप चैनल पर बने रहें, वीडियो को पूरा देखें तथा लाइक, सब्सक्राइब व शेयर करने के साथ ही साथ अपना वैल्यूएबल कमेंट देना ना भूलें. Let's start our discussion on the magnetic field at the center of a circular current loop using the Pathshala law. For this purpose, suppose we have assumed a current loop, circular current loop carrying the current I. We want to find out what will be the magnetic field at the center. For this purpose, we have divided this current loop into a small current element. One of the current element is shown here. Suppose that is a dl. Because of this dl, we want to find out what will be the magnetic field produced at the center. So using the Pathshala law, we can write the strength of the magnetic field produced at the center will be equal to mu naught by 4 pi I dl sin theta by r square. Where this sin theta is the angle between the axis of the current element and the position vector of the observation point with respect to the dl. Here we can say that, we have drawn the dl, the axis of the dl and the position vector with respect to the dl is making an angle of 90 degree. So instead of here sin theta, instead of the theta, we can write the angle 90 degree and the sine of 90 degree is equal to 1. So we can write mu naught by 4 pi I dl sine of 90 degree by r square. And sine 90 degree is equal to 1. So we can write mu naught by 4 pi I dl by r square. This will be the magnetic field produced by this small current element dl at the center. Now if we want to calculate the total magnetic field produced at the center because of this current element, then simply we have to integrate, or we have to add up the magnetic field produced by such kind of all the dls. So simply we have to calculate this one, equation number 1. So we can find out the net magnetic field at the center. dB can be written as integration of the dB, or here we can write dB from the equation 1, we can write mu naught by 4 pi I dl by r square. Very easily we can see that mu naught 4 pi and I r square, all these are the constant number, so we can take it outside. So we can write mu naught by 4 pi I by r square, and we have to integrate the dl. If we want to integrate the dl, or we want to add all these dls, then it will be equal to the circumference of the loop. So instead of this integration of the dl, we can write 2 pi r. So dB will be produced to integration of the dB. This will be produced to b is equal to mu naught I by 4 pi into 2 pi r. So we can cancel out this here and r to r. So it will be converted to mu naught I by 2r. This will be the net magnetic field produced at the center of the circular current loop.